All right. Some of these are ones that we've already talked about. Some of these are ones that you clearly need to be reminded of. So let's talk about them. Starting first with our thymus. Where do you find the thymus again? Remember, the thymus is that gland that sits over the heart. This is an infant's heart when that thymus is at its largest relative size, right? Even if it didn't grow at all, would it still cover my heart as much as it covers the baby's heart? No. But on top of that, not only do we grow and it doesn't, but it actually shrinks. By the time we get to be ancient, in our 50s, then this pretty much is indistinguishable from the connective tissues and fats that wrap around the heart. But it doesn't mean that it isn't there. It is still there, and it does still serve an important function. Our thymus produces a special hormone called thymosin. Thymosin is a circulating hormone, but there is something a bit unique about it. What is the target of thymosin? Yeah, where? In the thymus. It pretty much targets itself, right? It basically targets its own thymus tissue. To do what? Yeah, to mature T cells, to mature those lymphocytes, drive that process of the positive and negative selection we talked about to make those T cells immunocompetent. All right? How do you think it's regulated? It's not? Humoral based on what? Yeah, basically one of the main ways it's regulated is indeed humorally by the number of T cells that are present, right? We count how many T cells are in the blood, and if that's down, we need to mature some more, right? There are other factors. It's like most things, it's far more complicated than that, but that's a good starting point. Humorally by the number of T cells is good for that.
Be humorally by the mature T cells in the blood?
Yes. Yeah. Well, I think if you're saying T cells, then arguably they are mature, right?
Okay.
But yeah, I certainly wouldn't mark you wrong for saying mature T cells. All right. Pineal gland. I put the half-head chart up here. Anyone remember where the pineal gland is? Right here. Back of the brain, right underneath the corpus callosum, right posterior to the thymus, to the thalamus, and to the posterior commissure, right? Also sometimes referred to as the third eye. Also sometimes referred to as your sixth chakra, right? And what is it that the pineal gland does? Produces melatonin, which, as we talked about, makes your skin dark. No? What does it do? Oh yeah, it's the one that regulates your sleep cycle. Anyone know how we actually know this? Right? There's always been this question, and this is probably the best class to ask that in, right? How many of you got up this morning, just woke up smiling on your own? Anyone? Or was it that alarm that got you up this morning? Or in my case, was it your wife shaking you awake 20 minutes after your alarm was supposed to go off because my alarm, while going off, wasn't making any noise? Thanks, watch. So yeah, it was sitting on its base, charging, going off, and not making any sound at all. But luckily my wife woke me up, so here I am for you now, right? No. Primarily, when we get up, when we go to bed, even when we eat, are pretty much driven by social forces. Right? You didn't necessarily have breakfast when you wanted to. You had it because you were either in the car on the way here, or you had a 15-minute break in between classes, or all sorts of other social pressures determine most of the factors of our lives. But birds know when to get up, when to eat, when to go to sleep, and they don't even have watches. They even know when to migrate, to go south for the winter. So how is that? Well, they obviously have an internal clock. And so the big question became, do humans have the same thing? And in ancient times, and by ancient times I mean the 70s, when there was this glorious place called college, right? College is not the things that we're experiencing here when we all have jobs and real lives and all these kind of things. College in the 70s was when basically you graduated high school, you went to a 4-year university, and when you're at that 4-year university, the first year of college, you were required to take a psychology class. And that psychology class was basically an opportunity for the instructors to torture you. Right? We've all heard some classic examples. The prisoner's dilemma at Stanford is probably one of the classic examples of that. But another great example was they were curious about this internal clock and whether or not we had one. So what they did is they took a bunch of freshmen and they locked them into their own individual rooms in a basement. Right? No windows, no clocks, no TVs, nothing that would allow them to keep time. They had control of their own light switch, they had books, they had food, and basically they could set their own schedule. And what they found is that actually after a couple days of acclimation, people got on a fairly regular schedule, where a person would wake up at pretty much the same time every morning, eat at pretty much the same time, go to bed at pretty much the same time. Interestingly, the average cycle was actually 25 hours, not 24 hours. But people did get on a fairly consistent cycle. And in doing blood tests in these individuals, what we found is that one of the primary causes of that is a hormone called melatonin. Melatonin basically is a hormone that builds up in our body during the course of the day and leads to fatigue. And when we sleep, melatonin is broken down. Right? And so by the use of melatonin, we can pretty much set a cycle. Now, most of you hopefully haven't been locked in a basement for weeks on end. But many of you may have flown back to New York or England or something like that for the weekend. And you get off the plane in London and you're ready to have dinner and go out and party the night away, and what's the problem?
Tired.
Well, okay, yeah, the problem is everybody there is getting up for breakfast and getting ready to go to work. I heard you guys say it, but what do we call that? Jet lag, absolutely, right? What's the other way we take advantage of this? Or let me rephrase that. What's the other way that we horribly abuse this?
Take melatonin.
There you go, right? If you can't sleep, what do? You take a melatonin pill, right? And it makes you sleepy and it goes to bed. However, as we've talked about in this class, what is the primary way that we regulate hormone levels in our blood? Negative feedback. Exactly, negative feedback. So, if you take a pill that increases the melatonin in your blood dramatically, what's your pineal gland do? Oh crap, there's way too much melatonin. I need to stop producing it. And you suppress the production of it. So then the next night, when you don't take that pill and you've been suppressing your melatonin production all day long, what happens? You can't sleep. So what do? Take another pill, which suppresses it even more, and take another pill, which suppresses it even more. All right, it's one of the worst things you can do for a healthy sleep cycle is to take melatonin because it disrupts that normal process. How is it regulated? Yeah. So what would that be? Neural. Via the eye, or the optic nerve, absolutely. Yeah, remember I mentioned it's the third eye, right? Because it does actually get direct inputs from our retina. Light is one of the major factors that influences it. And again, there are ways we use this to our advantage. If you do decide to travel to London for the weekend, when the first morning that you're there, get up at sunrise and just sit out on the front porch and take in an hour's worth of sunlight. And sitting there and taking in that hour's worth of sunlight can dramatically reset your melatonin levels and actually help to mitigate the issues associated with jet lag. Right? We also take advantage of this in the way we treat our kids now. Right? In ancient times, kids were scared of the dark, so we had these light bulbs. You'd plug into the light socket, and it'd have this nice illuminated light that would fill their room during the night, keep the monsters away, so that they could sleep. The problem with that is if it produces too much ambient light, that excess light can stop their ability of producing deep sleep and can disrupt their ability to break down melatonin and affect their sleep cycle. So most sleep aids now for kids are things on a timer, right? Some little stuffed animal they sit on, they push the button, It flashes stars on their ceiling, they get a little bit of light, they fall asleep, in 20 minutes that goes off, right? Allowing them to have that dark light, and without that ambient light, they're more likely to get more meaningful, more restful sleep, right? That's why it's important to make sure that you have your lights off. Don't fall asleep with the TV on at night and things along those lines. Try to have darkness in your room to get more meaningful sleep, to help us to regulate our melatonin levels. So absolutely. It is neurally via light or via the eye or the optic nerve, however you wanted to describe that. Yes?
Last night I crashed on my bed, right?
Okay.
I had all the lights turned on, yet I fell asleep. So
Well, I mean, yeah, there's plenty of people who fall asleep in the afternoon when the sun is out. There's plenty of people that fall asleep in front of the TV all the time and things along those lines. Yes, but having things like that occur habitually can affect your ability to get deep, meaningful sleep and can disrupt your normal sleep cycle.
So people that like live in Alaska, they're all jacked up, right?
Yeah, or it doesn't even have to be as high as Alaska. Minnesota and places like that during, in the winter where you don't get as much sunlight and things along those lines. Or, yeah, like Alaska where you have, days on end or you have, nights on end. Absolutely, those can be issues. So often they will have major blackout, blinders and stuff like that to their sleeping rooms in those situations so that they can get that deep sleep.
What exactly is the target?
The target is the hypothalamus and the anterior pituitary.
And how come it's regulated neural?
You mean
It's
what?
anterior pituitary, but it's regulated neural.
No. The pineal gland and its production of melatonin is regulated neurally. Melatonin targets the hypothalamus and the anterior pituitary. And again, plays a role in that alertness and our sleep cycle. One and a half people got this right on the first exam.